So now I'm going to go ahead and take care of sector area and arc length. So what we're doing with sector area and arc length is that we're going to go right off of what we did when we found circumference and area. So again, circumference is the perimeter of the whole thing. This is 360 degrees, is the measure of all the way around. And we're going to take a percent of that. So when we find circumference, it's just 2 pi r. And we're going to take a percent of that circumference. Say we just want to do this much of it. We want to find just this length right here. Call this AB if you want. All right? So this little length right here, piece of string, if we put it along here, we want to measure that. And we're going to do the same thing for area of a circle. Now area of a circle is pi r squared. That's the whole thing. So what we're going to do is we're just going to take an area of this, say, pizza pi, all right? And find the area of just this. Well, that's going to be times a percent. So our formulas are pretty straightforward. Now, I don't really care for this rendition of it, but it's still perfectly fine. I tend to do 2 pi r for geometry over measure of the arc over 360. Okay? I don't actually write AB. I just do m over 360. So I'm doing circumference times part over whole. For area, I'm doing pi r squared times part over whole. That's all we're doing. So it's actually a pretty easy formula. So let's go ahead and knock this out. And again, this is out from an older textbook, but it's pretty much the same in all the textbooks. You're going to need an r, and you're going to need the measure of the arc. And you just plug those in. All right? You're going to use pi button on your calculator. So here's our first example. Find the exact length of EF. So what we're going to do here is we need our R, which is 6, and our measure of the central angle is 120. So we're looking for this length right here. So I'm going to do 2 pi r times m over 360. N goes to 6, n goes to 120. 2 pi times 6 times 120 over 360. Now, if you're using a calculator, you just type it in exactly the way you see it. If you're on the SAT or something like that, you may need to do this by hand. And that's nothing more than 1/3. 1/3 into 12 is 4, and you're going to get 4 pi. So whether you do it by calculator or hand, you get 4 pi. And this is the exact. If you want the approximate, you're going to have to toss that puppy in the calculator with the pi button and get about 12.57. And this is going to be units, all right? Okay, so let's take a look at another example. Here we want to find the exact length of AB. And this is going to be this arc right here. It's a minor arc. So we're going directly from A directly to B. So if this is 210, we subtract it from 360, and we're going to get 150 degrees. That's the M. Okay? So now we're going to do 2 pi r times m over 360. I suggest always writing your formulas down. N goes to 5, so that's 10 pi times 150 over 360. And that's exactly what I put in the calculator right here. And I got 25 pi over 6. That's the exact. If I said approximate, or I didn't say anything at all, you get to choose. And that's going to be about 13.1 units. Okay? So this is, again, exact. All right? And you're going to work with the exact a lot in your future classes. A rounded answer would actually be hardly impossible because it would be no calculator courses likely. All right? So sector area. So when we find sector area, it's just basically a slice of this. It's like a slice of pizza. We're finding the area of this right here. It's going to be a percent of the whole circle. So the whole circle is pi r squared, and we're going to take a percent of that. So real quick, here is my measure of the arc is 120 degrees. There's my radius. So we're just going to plug it into our formula of pi r squared times m over 360. So in goes my r, so pi times 6 squared times 120 over 360. We already established that's just 1/3. 1/3 of 36 is going to be 12. So when you put this in the calculator like I did down here, you're going to get 12 pi. And this is units squared. You could put that in the calculator again using the pi button, and you're going to get about 37.7. Okay. Units squared. That's pretty much it. These are actually pretty darn easy. Just practice a few of these. So this is, I think, our last example. So we have our R3, our M is equal to 20. And I have other examples on YouTube where you're given the area, but you're looking for the measure of the arc, or you're looking for the radius. So you definitely want to practice those if you take any future classes that involve this. So in it goes. So we're looking for area, so it's going to be pi times 3 squared times 20 over 360. Knock that in the calculator. I mean, you could do this in your head if you wanted to. That's 2 over 36, which is just 18. 9 over 18 is 1/2. You're going to get pi over 2. And that's approximately 1.57. All right? And that's going to again be units squared. Okay? So that's my approximate value. And I believe that is it. So I'll get this uploaded to YouTube here shortly as well.